Okay, keep reading. Thermodynamics. Very easy chapter. In this में thermodynamics में they removed the Carnot engine. They removed. Okay. Second law of thermodynamics is there. Reversible and irreversible process is there, but Carnot engine they removed. So वो deleted वाला मत पढ़ो. Time waste process. Okay. So thermodynamics क्या है? It is a branch of physics that deals with the heat, work, and energies and their transformations. This chapters में पूरा heat, work, energy, and the heat, energy, and transformations we are studying. And thermodynamics में क्या क्या topics are there? Thermal equilibrium के बारे में पढ़ रहे हैं. Laws of thermodynamics we are studying, and thermodynamic process we are studying. Okay. Laws में we have zeroth law, first law, second law we are studying a statement only. There is no numerical statement. And first law is the base, complete numericals will be coming from first law. And zeroth law is a theoretical. Why the name zeroth law came? Because they discovered the first law. बाद में they understood that okay, this is a fundamental property should be there. Okay, they put before first will be zeroth word. Okay. Okay. Now, first one we're studying. Means आपको मालूम है thermal equilibrium means two bodies are in thermal equilibrium when the two bodies will have same temperature. That is the important thing. दोनों should be having a same temperature. देखो, two systems are said to be in thermal equilibrium when they have same temperature and no net heat flows between them, even they are at thermal contact. Even though they are in thermal contact, no heat flows from one body to other body. That means if the heat is not flowing, means nothing but temperature is constant. Okay. देखो, suppose body A is there and it temperature TA, and other body is there at temperature TB. Okay. And in between, I am putting a diathermic wall, or we can call conducting wall. बोलते diathermic wall को we called as conducting wall. लगाने से क्या होगा? मान लो initially the temperature is TA is greater than TB. Okay, TA is greater than TB. What will happen when the temperature is greater than, and outside we are putting insulation so that heat will not flow away. Okay, so after certain time, क्या होगा initially the heat transfers from one body to other body because this is at high temperature, this is at low temperature. बाद में after certain time के बाद क्या होगा? What will happen after certain time के बाद? TA will be equal to TB. When the temperature is becoming same, that's why heat transfer is stopped. Heat transfer stopped. Therefore, heat transfer stops and thermal equilibrium is achieved. So when after certain time के बाद both will be equal and finally thermal equilibrium is achieved. This is what thermal equilibrium is. Two bodies are in thermal equilibrium when the temperature between the two bodies are same. And conducting wall को we call as diathermic wall. And insulating wall को we call as adiabatic wall. Adiabatic and diathermic wall का याद रखना है. And this is chapter where 8 mark question is coming from this. And this is a purely formula based chapter.
Yeah, sir.
Okay, sir. No. Because temperature is the physical quantity that decides the heat flow. olden days में which is deciding factor of heat flow बोल के they understood that there is a one physical quantity called temperature. उसका नाम दिया है temperature बोल के, तभी नाम दिया है. Okay, and that's why the zeroth law they given. Temperature is the temperature base में they given the zeroth law. Okay. So tell me, if we use adiabatic wall means it is a non-conducting wall between them. What will happen? Whether it can reach the thermal equilibrium. If I use,
Yeah.
how can reach thermal equilibrium? Tell me. If TA is greater than TB.
There'll be no heat flowing.
There is no heat flowing, then क्या होगा? They are at different temperatures, right? Whether two bodies are in thermal equilibrium means no. These two bodies are not in thermal equilibrium. So answer is no. Two bodies are not in thermal equilibrium. So two bodies are thermal equilibrium only when what will happen? When forcibly stop करने की जरूरत नहीं है. मतलब लगाने contact करने के बाद also it should not flow. Here heat is not flowing because of adiabatic wall. Okay, अगर मैं remove करूँगा when I put a diathermic wall, heat is transferring. So they are not in thermal equilibrium. Okay. Individually thermal equilibrium can happen. Individual body can be thermal equilibrium. If the temperature, everything will be constant, then individually we can tell this is thermal equilibrium. It is not changing with time. But two bodies are in thermal equilibrium only when temperature of the two bodies should be constant. Okay. Sure. Now we will start with the zeroth law of thermodynamics. Zeroth law of thermodynamics. So what is zeroth law? States if two thermodynamic systems are in thermal equilibrium with the third one, then they are in thermal equilibrium with each other. This is a basic one, easy. देखो, suppose मान लो there is a two bodies A and B. Okay, they are देखो it is nothing but the adiabatic wall. ये वाला adiabatic wall. Okay, and this wall is nothing but the diathermic wall. Diathermic means conducting wall. Okay, now देखो individually if you see A and C after certain time के बाद they become thermal equilibrium, right? Similarly, B and C after certain time के बाद they become thermal equilibrium. Okay, after certain time के बाद if I remove this diathermic wall, adiabatic wall, and I place a diathermic wall, then they observe that these two are also in thermal equilibrium. These two are also thermal equilibrium. मतलब meaning क्या है? Initially, A and C are in thermal equilibrium initially. That means TA is equal to TC. Then B and C are also in thermal equilibrium because बीच में कौन सा wall है? Diathermic wall is there. That means TB is equal to TC. After certain time के बाद, if you see that देखो TC, that means indirectly from this I can conclude TA equal to TB. That means A and B also are in thermal equilibrium. Okay, so that means इसका initially संबंध नहीं है. You can tell, you can compare with real life. Suppose A and C are friends, B and C are friends, then indirectly A and B are also friends, right? So इसका इनिशियली दोनों संबंध नहीं है. ये दोनों थर्मल इक्विलिब्रियम में अलग से, ये दोनों थर्मल इक्विलिब्रियम में, बट आफ्टर सर्टेन टाइम के बाद दिस टू आर बिकमिंग थर्मल इक्विलिब्रियम. दिस इज ओनली zeroth law, the basic law, fundamental law. That's why they put before first law, zeroth law. Okay, so zeroth law done. Now to understand first law, copied it.
So, I'm drawing the figure.
Yeah.
Yeah, sir, done.
Okay. So zeroth law done. Now, to understand the first law of thermodynamics, we have to know three variable parameters. Concepts are internal energy का symbol है U, and we have to know about the heat energy के बारे में we have to know, and we have to know work के बारे में. इन तीनों का relation only your first law of thermodynamics. That's why we are studying separately internal energy, heat, and work done separately. Then we are combining to make a first law of thermodynamics. That's why first internal energy, उसका internal energy क्या है? इधर only here only will get degree of freedom. उसका formula क्या है? Everything will learn from this. Okay. चलो internal energy के बारे में will learn. What is internal energy means? Basically, suppose in a container the molecules are moving. It has internal energy. कौन सा energy it has? Tell me. कौन सा energy it has? Potential energy of the molecules or not? There is a potential energy between the molecules. And दूसरा, since the particles are in motion, kinetic energy of the molecules. I'm talking, this is the internal energy of the container में, gas में, internal energy, these are the things, right? But in ideal gas में, we wrote the postulates, right? In kinetic theory of gases में, ideal gas में, one property we learned that there is no force of attraction between them. We are neglecting that force of attraction between the molecules. That means which one we have to neglect? We have to neglect potential energy of the molecules. Because by ideal gas, there is no force of attraction between them. If there is no force of attraction between them, there is no potential energy. So therefore, internal energy depends on the kinetic energy of the molecules only. So what is internal energy for ideal gas? It is only the kinetic energy of the molecules. Well, indirectly, if you find the formula for kinetic energy of the molecules, then the formula of internal energy will be ready. Okay. Now, kinetic energy में molecules are moving, right? कौन सा types of kinetic energy will be there? Tell me. कौन सा types of kinetic energy will be there? Because of straight line motion, translatory motion बोलते हैं. Then एक घूमेगा ना, rotatory motion, the molecules can rotate.
Rotational and translatory.
And दूसरा high temperature में vibration. These are the three different types of kinetic energies will be there. So therefore, internal energy can be nothing but kinetic energy molecules. कौन सा the kinetic energy molecules? Translation, rotation, and vibration. देखो. Now धीरे-धीरे क्या कर रहे हैं हम लोग? We are trying to find the kinetic energy formula. Then that is the formula for internal energy. Famous formula आएगा. वो तो सबको like करते हैं formula. Okay? देखो. Why we are neglecting potential energy of molecules? Because of ideal gas assumptions. Assumption में the force of attraction is, there is no force of attraction. Therefore, potential energy is zero. So internal energy is nothing but neatly लिखो, notes लिख लो. अभी बाजू में आप बुक रख के इसे देख कर टाइम पास मत करो, लिखो अच्छे से. सिस्टमेटिक लिखे तो अच्छा रहेगा. But now to understand this kinetic energy of the molecules, some kinetic energy का formulas है ना, then only we can get the internal energy formulas. So kinetic energy आने के लिए आपको degree of freedom के बारे में learn करना पड़ेगा. Degree of freedom, which is I told you in kinetic theory में the EAMCET में they'll give the book में, but we are learning in thermodynamics में degree of freedom क्या है. Okay, चलो. So we learn degree of freedom. We represent as F. Degree of freedom. So what is degree of freedom? आता है degree of freedom means anything? मानो बोलो.
Sir, do not definition.
Definition बोलो. Okay, चलो. Definition को the number of independent terms in the expression freedom means the number of independent terms in the expression of kinetic energy. How many ways are there for kinetic energy for that molecule? It can be rotation, it can be translation, it can be movement, right? Vibration, right? So in some number of एक molecule कितना है? That expressions are कितना है? That is nothing but the degree of freedom. Okay, we will see now. उसके बारे में क्या क्या है? How to learn this one? We will see. And you know moment of inertia का formula in terms of omega, tell me. Moment of inertia याद है? रोटेशन में बोलो, रोटेशन में नॉर्मली mr square, right? mr square is a model. तो दूसरा in terms of omega में
omega square I.
Okay, that will be useful here. Now देखो, now degree of freedom में, degree of freedom में different gases में we are running. One is monoatomic gas. Monoatomic gas example क्या है? Helium, neon, argon. Monoatomic means एक ही, there is no molecule, right? Only एक ही atom का. You tell me, इस atom का there is a chance of moving along the x direction. Tell me, kinetic energy will be there in x direction or not? Tell me, kinetic energy is there. It can go in y direction also. It can go in z direction also, right? But you tell me that small molecule, it can also rotate, right? It can also rotate about y direction. What is the formula for kinetic energy? Half I omega square, right? Half I omega square. देखो, moment of inertia for this molecule about rotation is very small. Why? mr square, right? Normally molecule ka r is very small. That's why moment of inertia we are neglect. That means we are not counting rotational kinetic energy in this. So rotational kinetic energy 0. And at high temperature only vibration we have to count. We'll mention at high temperature में vibration कितना count करने का? 2 count करने का. Always vibration में 2 degree of freedom extra add करना पड़ेगा. Okay. So that means here degree of freedom is how much? How many ways the molecule has kinetic energy? 3. So for a monoatomic gas ka degree of freedom is 3. Similarly, coming to the diatomic molecule. Diatomic molecule example क्या है? Oxygen, nitrogen, hydrogen. Oxygen का double bond है ना? Now first one translation होगा. It can move in x direction. It can move in y direction. It can move in z direction. That means 3 kinetic energies are there. Okay. Now coming to the rotational kinetic energy, देखो, it can rotate in the y direction. देखो, अगर y direction bond है ना, it can rotate like this, zoom बोल के. That means it has kinetic energy, right? Half I omega square. It also rotates in z direction. Z direction the molecule can rotate like this, zoom बोल के. It also having the kinetic energy. But x direction, if you see that r is very small, it has to rotate like this, right? The molecule bond has to rotate like this, right? When I rotate, the moment of inertia is very less. We neglect that one. That means we have how many kinetic energies? 5. Well, degree of freedom is 5. Okay, we are not counting vibration. Only when they mention at high temperature, then only we have to add +2 each one. +2 each one we have to add. That means at high temperature में diatomic molecule का degree of freedom will be 7 हो जाएगा. Okay, देखो 2 translation for this होगा. By we are negating x direction समझ में आ रहा है ना? Half I omega square, I is very small. Now coming to the triatomic gas or polyatomic gas का linear रहेगा, non-linear रहेगा. That one you understand. For linear में the degree of freedom is 5 only. The same reason which we are having. Non-linear में if you see, the degree of freedom is 6. Why? Because normally when you see the non-linear molecule, if you see the diagram, SO2, right? SO2 example I'm taking. SO2 is there. Now the molecule can go in x direction, y direction, z direction, and also rotate around the x direction, y direction, z direction. So we have degree of freedom is 6. Normally, whenever question may doubt mention, normally this is the standard one. If they mention that high temperature, we have to add +2. Tell me, Pranabolo, what is the degree of freedom for a non-linear molecule if vibrations are considered?
8.
Yes. Tell me, Manu, what is the degree of freedom for a triatomic gas for a linear molecule?
5.
Yes. Okay. So 3, 5, 5, 6. 3, 5, 6 is the basic one. Okay. चलो. Next. मतलब CO2 example देने से आपको sometimes mention नहीं करेगा. You have to understand. CO2 is a आपको linear molecule है. Okay, linear molecule है. That's why we have to use 5 बोल के आपको understand. Computed example monatomic, diatomic, triatomic, linear में degree of freedom डाल लो. And SO2 का example is 6. चलो. Now we are learning, why we are learning degree of freedom? Because to get the formula for internal energy. To get the formula for internal energy, kinetic energy से आपको find किया तो
So can you go to the graph of yeah, 1 second.
So internal energy का formula only we are learning. We want to get, if I try to find the kinetic energy of the molecule, then definitely internal energy formula will be same.
Yes, done.
Okay. Now this law say we'll get the kinetic energy of the molecule का formula will get from this law. That is called law of equipartition of energy. Name itself it will equi, मतलब equally we have to spread. Okay. So what is the law of equipartition of energy says? Average kinetic energy associated with each degree of freedom of a molecule is half kb into T. Where kb, you know, R by Na, Boltzmann constant, and T is temperature in Kelvin. So what is saying? Degree of freedom को, एक degree of freedom को, एक molecule को, the kinetic energy will be half kb into T. Now इधर से आपको एक formula आ जाएगा kinetic energy का formula. So understand, one molecule, what is it saying? The law is saying that one molecule, मान लो having 1 degree of freedom, then इसका kinetic energy will be how much? Kinetic energy will be half kb into T. This much energy you have to give for each degree of freedom for one molecule को. Okay, you tell me, for one molecule, suppose F degree of freedom. Tell me kinetic energy will be how much? Kinetic energy for one molecule I'm talking about.
3/2 kT.
3/2 नहीं है, F degree of freedom if talking.
Oh, then
F by 2
kT.
F by 2 kb into T. Right? Now we're talking about one molecule, but I want in terms of mole. 1 mole of molecule. 1 mole has nothing but Avogadro number, right? 1 mole has Avogadro number. So that means कितना होगा? 1 mole has Avogadro number. So Na into F by 2 into Kb is nothing but R by Na.
Sir, but if you take average, it'll always be 3/2, no?
हाँ, generally 3/2. Transaction में रहता है. Ideal gas के लिए 3/2 use करना पड़ेगा. Okay. So average नहीं बोलेगा. Ideal gas में mention किया तो you can take 3/2. Okay. So what you got? Na get cancelled. That is F by 2 RT. This is what kinetic energy of 1 mole of ideal gas. F by 2 RT. F is a degree of freedom. Okay. But I want kinetic energy of n moles. कितना होगा? N into F by 2 RT. This is a formula for kinetic energy of n moles. This is a famous formula. N into F by 2 RT. Now I already said the internal energy is nothing but kinetic energy, right? Internal energy is nothing but kinetic energy. Therefore, internal energy का formula आ गया. Internal energy का first formula thermodynamics में. Internal energy का formula is, or kinetic energy, both are same, right? Internal energy or kinetic energy is N into F by 2 R into T. N into F by 2 RT is a formula for internal energy. This is a formula. First formula we learned. N into F
Kb
by
is
2 R.
Boltzmann constant only, no?
Kb is Boltzmann constant. That's why we wrote R by Na. N into F by 2 RT. Sometimes that means indirectly you can see that internal energy depends on temperature. Temperature only. If there more temperature, more the molecules will vibrate and internal energy will increase. Internal energy depends only on temperature. Very important. Internal energy depends on only on temperature. If they ask change in internal energy, delta U चाहिए बोलते हो, temperature change हुआ तो ही internal energy change होगा ना. then only kinetic energy will change. So delta T that is equal to N into F by 2R into delta T. N into F by 2 R into delta T is a formula for internal energy of an ideal gas.
So then I get as NCV delta T, right?
that आगे आपको CV हो जाएगा. Internal energy but जब तक लग रहा है N into F by 2 R into delta T is the formula for internal energy. N is a number of mole and आपको मालूम है ना number of moles का formula given mass by molar mass. Sometimes the given mass and molar mass, you know, each. And F value we have to put as per the example, as per the given question में F by 2 it will. आ गया first formula? Then हो गया? Okay.
1 second.
1 minute.
Sir, kinetic energy of N moles is NFR T by 2.
Kinetic energy for N moles है तो N into F by 2 RT.
Okay.
This for 1 mole. For N moles means N से multiply करूँगा. N into F by 2 RT. And this nothing but the internal energy.
So sir, there's a one like just for like 1 mole of gas. So is it just a F by it doesn't depend on number of moles.
Number of moles depend on N. Kinetic energy of N moles means N into F by 2 RT. Avogadro number. This is Avogadro number. Okay, when we are converting molecule to mole has Avogadro number, right? So Na, kV to reverse R by Na. So it does not depend on Avogadro number, but number of moles depend over. Indirectly, trying to convert into N moles. So formula आ गया, internal energy का formula N into F by 2 R into T. अगर T में potential energy बोल तो N into F by R into delta.
Yeah, sir, done.
So done.
Formula आ गया ना? Formula वीडियो समझ. N into F by 2 R into delta T is the formula. देखो, now internal energy formula आ गया ना? तो हम डिस्कस करेंगे. So formula क्या है? Internal energy का formula is N into F
NF by 2 R delta T.
N into F by 2 R into delta T. 1 mole of monoatomic gas is heated from this much to this much at constant volume. Find the change in internal energy.
$300.
Yeah, sir, 300 R.
क्या कर रहे हैं?
So 300 R, no sir, R is if you do 8 point,
R वो 300 बोला.
so 2490.
R is 8.3 you can put there. Okay. R में इसका क्या बोला? Okay. 2490. Next. Find the internal energy of 2 moles of diatomic gas at 400 Kelvin. I want internal energy at this temperature. Diatomic gas बोला.
So 16,600.
2000 R.
R का मल्टीप्लाई कर लो. एग्जाम में R का वैल्यू मल्टीप्लाई करके दे रहा है ऑप्शंस में. 8.3 will take. calculate non-unity of using. That is correct. So it is 16,600 joules. 16,600 joules is the answer. So there are moles given, diatomic degree of freedom is 5. That's substituting. Next. So, ideal gas absorbs 200 joules of heat during isothermal expansion. Find the change in internal energy.
Zero.
Yeah, 0.
Because isothermal means temperature.
Yeah.
Yes. Next. Internal energy of 1 mole of monatomic gases is much. Find the temperature. Thank you.
So I got 30.
P.
Yeah.
Temperature is how much?
Oh wait, no, I did mistake. Wait.
So you wanted kelvins only, right? So I got approximately 300.
To 300.
Yes, 300. Next. Two gases have same number of moles, same temperature. Gas A is monatomic, gas B is diatomic. Find the ratio of the internal energy.
So 3:5.
Yes. Because it depends on the degree of freedom. So 3:5. Yeah?
Okay.
The gas is heated at constant pressure so that temperature becomes 3 times. Find the ratio of final and initial internal energy.
So 1/3:1 only.
देखिए a gas is heated at constant pressure so that the temperature becomes 3 times. कितना है प्रणव?
Sir, can I tell in terms of like wait no.
और ratio.
So basically I have to find change no.
By change, ratio of the final to the initial internal energy I'm talking.
So it
Ratio,
should be 3:1.
because it depends on the only temperature. Next, it's the same way. Same way. Delta U is asking F by 2 or B. Now we'll talk about heat. Heat के बारे में note करेंगे. I told you 3 parameters. कौन सा parameters है? Internal energy, heat and work done. तीनों अगर हो गया तो first law of thermodynamics will be relation between them. Okay. चलो heat के बारे में already we know Heat के बारे में what are things we studied? One is heat is a form of energy that is transferred between a system and surroundings due to temperature difference. देखो, when there is a temperature difference, heat transfer from higher to the lower temperature. Heat transfer from higher to lower. When there is a temperature difference, the heat will flow from higher to lower temperature. This one you know already. Okay. Now देखो, we studied about specific heat capacity. Specific heat is nothing but represented as small c. We learned in thermal properties of matter. Specific heat. Yeah, the definition. Specific capacity.
The amount of heat required to raise the temperature of unit mass by 1 degree.
1 degree से 1 degree रेस को इंक्रीज करने के लिए कितना हीट देना पड़ेगा? That is specific heat capacity.
Can you show the definition of heat?
हाँ.
Yeah, Sudan.
So specific heat capacity का. So small c we learn that small c is delta q by m delta t, right? The amount of heat energy required to raise per unit mass per unit degree Celsius. This is nothing but from this what we learned delta q is equal to m c delta t. Small c, which we learned in thermal properties of matter. Okay, but in this way we have to learn. This one like that. In this way we have to learn. We have to learn molar specific heat capacity. That is important for us. Thermal properties में we learned about this is through mass code, but I want gas right here. We are talking about moles. That's why it's called molar specific heat capacity or intention.
So is it only by Celsius and not by Kelvin?
This is नहीं
You need to get
इतना नो प्रॉब्लम 1 केल्विन को इंक्रीज करने के लिए कितना हीट देना पड़ेगा? It is also specific.
yeah, Sudan.
Now we have to learn molar specific capacity, which is written as capital C. Very important. देखो मानो, देखो अच्छे से क्या पढ़ रहे हैं? So molar specific capacity, the amount of heat required to raise the temperature of 1 mole of a gas by 1 unit degree Celsius. This is nothing but आपको capital C है. So क्या है? Capital C is delta Q by N delta T. We want this capital C we want because gas का moles वाला है ना. So from this delta Q का फॉर्मूला क्या होगा? N capital C delta T. N capital C delta T. And we have a relationship between them also. Relationship between capital C and small c. So देखो capital C we know this form, right? Delta Q by N delta T. And N is nothing but delta Q by given mass by molar mass, right? This is the number of moles का formula. Given mass by molar mass into delta T. Okay. Now cross multiply करो ऊपर. Capital M delta Q by M delta T. And what is delta Q by M delta T? Nothing but small c. M into small c. So therefore, capital C is equal to capital M times small c. This is a relation between molar specific capacity, which is capital C. Capital is required for us now, and small c, which we learn in the thermal properties of matter.
So what's the relation between molar and normal heat capacity?
Sorry. Capital C is equal to small capital M into C. And this
So capital M is mass of or number of moles?
is
Capital M is
Molar
number
mass.
of mass.
molar mass. This one. Okay, and this is nothing but molar specific heat capacity. Molar specific heat capacity. And small c is what? Simple specific heat capacity. This is mass wala. This is moles wala. This capacity. So heat के बारे में पढ़ते details में. Okay. Then
Yeah, Sudan.
okay. Now we have types of molar specific capacity. Already you know, same definition only, but at constant pressure, and this is at constant volume. Molar specific capacity at constant pressure, molar specific capacity at constant volume. So definition क्या होगा constant pressure में? That is called CP बोल के आएगा ना, यही है. It depends on the amount of heat required to raise the temperature of 1 mole of a gas at 1 degree Celsius while keeping pressure constant. ये एक ही sentence ऐड करने वाला है, pressure constant. Similarly, same definition only by volume constant. This is the CV. Okay, because heat depends on constant pressure, constant volume, that depends. Based on that only, definition will change. Now, इसका formula क्या होगा? Delta QV कितना होगा formula? In terms of constant pressure, NCP delta T. And here, delta QV कितना होगा? NCV delta T. So, heat depends on compulsory which process we are doing. These all numericals ना बहुत detail में जाना पड़ेगा इसमें.
So, but isn't heat always NCV delta T?
No, heat is not NCV delta T. Internal energy only NCV delta T.
Oh,
Heat,
yeah.
Heat will be changing based on the process. Always very important. NCP delta T and NCV delta T. Question में mention करेगा. Based on that, you have to follow.
Yeah, so done.
Then, okay. Now CP in terms of degree of freedom में लिखने वाला है. You know it already. CV is nothing but F by 2R. This is a formula we have to learn. CV is F by 2. Because CV in terms of degree of freedom. And we have Mayer's relation. याद है ना? Chemistry में पढ़ा. CV minus CV is equal to R. This is a Mayer's relation. Now if I substitute CV के जगह में F by 2R, when you send this side, CV will be how much? F by 2 plus 1 into R. These two formulas you have to learn. CP is F by 2 plus 1 times R. And CV is F by 2R in terms of degree of freedom. And Mayer's relation मालूम है ना आपको? Any CP minus CV will be always R. Now since you know F by 2R.
But this is only for like 1 mole, no? CP and CV.
1 mole. Okay. Now देखो, since you know CV is F by 2R, हम लोग क्या learn किया? इंटर एनर्जी का फॉर्मूला क्या हुआ कल में? इंटर एनर्जी का फॉर्मूला N into F by 2RT, right? So therefore it becomes what? NCV delta T. Very famous formula. Let's say NCVT, and when a change in इंटर एनर्जी का, change in इंटर एनर्जी का NCV delta T. NCV delta T का इंटर एनर्जी का बोल देगा people. NCV delta T. देखो, it depends only on the molar specific heat capacity constant volume only. आपको जो भी प्रेशर होने दो, कुछ भी चेंज होने दो, आपको CV लगाना पड़ेगा. And CV is nothing but F by 2R. Okay. So obviously formula will be NCV delta T formula you have to learn always. Okay.
Yeah.
Now Mayer's relation में I can write in terms of small c also. कितना होगा? This is m times.
So it will be NR.
Huh?
If you're writing small c minus small c
नहीं,
will be
small c का क्या relation है? Tell me. M times of small cp minus m times of small cv is equal to R. So m common लिया तो cp minus cv is equal to R. Therefore, cp minus cv will be R by m. ये mass वाला, मतलब thermal progression में सीखा ना that one. So cp minus cv is equal to R. This we are our intention is to get the capital C only. We want capital C, molar specific heat capacities. Small c already we studied in thermal progression of matter. So therefore, आपका क्या है? Cp minus cv is R by m बोल के we did it. And molar mass rate it should be in kgs.
So m is molecular weight of that gas.
मॉलिक्यूलर रेट नहीं है, मोलर मास ऑफ इन केजीएस में डालना पड़ेगा.
So sir, that's Cp minus Cv.
हाँ, Cp minus Cv is small Cp minus small Cv is nothing but R by M.
Oh, okay. Yeah.
Okay. चलो. Now we have to know one terminology, adiabatic index. Adiabatic index को और adiabatic constant भी बोलते हैं. It is gamma. Represents gamma. Okay, gamma क्या है? What is this one? The ratio of specific heat capacity at constant pressure to the constant volume is called as adiabatic constant or adiabatic index. I know that's nothing but Cv by Cv, right? Cv by Cv, Cv you know f by 2 or f by 2 plus 1 by f by 2. So if you take LCM उल्टा किया तो क्या होगा? 1 plus 2 by f. 1 plus 2 by f. Because Cv is f by 2 plus 1 times of r, right? F by 2 plus times of r and f by 2 r. So r cancel. F by 2 आपको उल्टा किया तो you'll get the answer as 1 plus 2 by f.
So what's the symbol of it? Gamma.
Gamma. Gamma. Gamma is nothing but Cp by Cv. तो इसमें क्या पूछेगा एग्जाम में आपको? गामा फॉर मोनोटॉमिक गैस कितना होगा? गामा फॉर मोनोटॉमिक गैस.
So it'll be 5 by 3.
Degree of freedom will be monatomic. Gamma is more in this one.
So more for diatomic.
Why? Degree of freedom कम है तो more adiabatic constant, right? Gamma value. That means किसका ज्यादा है? Monatomic is ज्यादा है. देखो, a degree of freedom increases as gamma decreases. That is important. That means if I can tell gamma of monatomic greater than gamma of diatomic greater than gamma of triatomic. So 1 plus 2 by f is the formula. Because questions में आपको कैसे रहेगा मालूम है? Sometimes they'll give in degree of freedom, sometimes they'll give in terms of R में ऐसे देगा. So you have to know conversion Cp Cv से different forms में you have to know.
Yeah, sure.
Yes. One more Cp Cv का formula. Cp Cv in terms of R and gamma. Formula बोल सकते हो? Cv in terms of R and gamma में. देखो. We know that gamma is nothing but
So 1 by gamma minus 1.
no Cp
R
by
by
Cp. From this, what is Cp is equal to gamma times of Cp, and we know Cp minus Cv is equal to R, right? Cp के जगह पे I'm substituting gamma times of Cv minus R and taking common. I got Cv is equal to R by gamma minus 1. This is very important. R by gamma minus 1. If I know Cv, I can get Cp directly. Gamma से multiply करने का gamma R by gamma minus 1. Very important. This two formulas से होगा. Cv का formula से ये फार्मूला शीट पूरा आपको देना पड़ेगा.
Yes, we're done.
अच्छा. Yes.
Yes, sir.
चलो नेम प्रेस करेंगे. So फार्मूला आ गया ना? Resolve numericals based on that. Tell me formulas first back करो. Internet
Yeah,
का
yes.
चाहिए.
I learned the formula.
Yeah, tell me. CV in terms of R and gamma. CV.
R by gamma minus 1.
CP.
So you add the R to it.
Gamma R by gamma minus 1. Because CP, gamma is CP by CV, right? So
Yeah.
CP is nothing but gamma times of CV. That's why we have to multiply that's it. Okay. Change in internal energy का formula, delta U का formula.
NCV delta T.
Okay. CV in terms of degree of freedom.
F by 2.
F by 2 R.
Oh,
And
yeah.
CP in terms of degree of freedom.
1 plus 2 by F. No, that's gamma. CP is
F
1
by
plus
2.
F by 2.
F by 2 plus 1 times R.
Yeah.
Okay. Now tell me what is the CP minus CV is equal to? Molar work.
CP minus CV. R.
And for specific heat wala?
R by M.
Okay. Tell me CP in terms of degree of freedom. CP in terms of degree of freedom.
1
F by 2 plus
F by 2 plus 1.
times R bhul ja rahe ho.
Yeah.
R is important. Compulsory. Okay.
Yes.
So heat depends on the method of process. Okay. CV or CP depend on the. Okay. So देखो. 1 mole of monatomic gases is heated at constant volume from 300 Kelvin to 500 Kelvin. Heat supplied is how much?
300 R.
R is 8.3. 2 moles of monatomic gases are heated at constant pressure. So CP find करना पड़ेगा आपको. Since it all talked about monatomic, degree of freedom is 3.
1500 R.
Okay. Next. 1 mole of monatomic gases heated for constant pressure. Heat absorbed. This is diatomic. Yes.
Yeah.
कितना?
250.
I don't think.
Oh, constant pressure. Oh, shit. Yeah.
मतलब वो देखना पड़ेगा. क्या heat depends on constant pressure or constant volume. Constant pressure का formula क्या था? F by 2 plus 1 times of R, right? CP is equal to F by 2 plus 1 times of R. Since he told diatomic, degree of freedom is 5. So 5 by 2 plus 1 is 7 by 2 times of R. Now formula is called NCP delta. So heat depends on constant process you are doing. Okay. For the same rising temperature, find the ratio of heat absorbed by the monatomic gas at constant pressure and constant volume.
So it'll just be gamma.
No, we have to find the ratio of heat absorbed by monatomic gases in constant pressure में separately, constant volume में separately. मतलब इसका divide करने का ratio. मतलब heat absorbed in a monatomic gas at constant pressure by heat absorbed by the monatomic gas at constant volume ratio.
So is it 5 by 3?
Yes, correct. Because CP by CV, right? That is मालूम है formula मालूम है ना वो use करेंगे 1 F by 2 plus 1 times of R by F by 2. Okay. So these are the 2 parameters we learned. अब next class में we will learn about work and उसका first law of thermodynamics.